For this one, it's a product rule. But when we use the product rule, we're going to find that when we come to this derivative, we're going to need chain rule. So let's see how this one goes. Let's start off by doing f prime of x equals, what does the product rule say? I first do the derivative of this first factor. What's the derivative of x squared? Of course, it's 2x. Then I multiply by this factor left alone. Plus, now I leave this first factor alone, and I multiply by the derivative of this factor. So here's where the chain rule comes in. In order to do this, I kind of ignore the thing in brackets here, and I kind of pretend like it's something to the power of 1/3. How do I do a power derivative of a power like that? Well, we're pretty used to that. We bring the 1/3 to the front. Then we have whatever's in the brackets. Then we do 1/3 minus 1. What is 1/3 minus 1? It's negative 2/3. And then afterwards we multiply by the derivative of what was in the brackets. Let's fill those quantities in. So there we go. Unfortunately, we have to just recopy all of this stuff in order to do that simple little derivative at the end. You know, I sometimes see teachers, they just erase this and then they write the answer in, and I find that's really sloppy. And students do that too. If you want to get answers correct, you really should take the time to, you know, recopy your line. And even though we recopied all of this stuff just to do this simple little derivative here, I still think it's a good idea, because otherwise when you start erasing stuff, it just gets messy and you lose track of what you had. And if you ever make a little mistake, it's hard to backtrack and see where that mistake occurred. Anyways, what is the derivative of this little guy? Well, the derivative of this is 0. Minus 3 times 3 is minus 9, x to the power of 2. Okay, so the derivative is actually done. If we didn't have to simplify, we could stop now. But I think it's often the factoring at this stage is the more challenging part than the derivative. How do we factor this to make it as clean as possible? Later on, when you graph functions and do other types of applications with derivatives, you really need to factor these expressions and get them in the best form possible. So it's definitely worth our time to try to get good at that. Well, what I would suggest maybe first of all is, well, what's jumping out at me? I see this minus 9 and this 3 here. We could cancel those off and make a minus 3. Minus 9 divided by 3 is minus 3. And x squared times x squared is x to the 4th. So why don't we just do that before we even try to do any factoring? So like I said, we have a minus 3 here. Y again, minus 9 divided by 3 is minus 3. X squared times x squared is x to the 4. And this stays still. Now here's the important step. Notice we have 1 minus 3x cubed here and here. That means we can pull it to the front. And we also have x in common. I could do that in 2 separate steps, but I hope you're feeling confident I can do it in 1 step. I'm going to factor both of those to the front right away. Now, how do we know what power to put on this 1 minus 3x cubed? It's always the smallest one. 1/3 and minus 2/3. Which is the smaller number there? It's minus 2/3, of course. So that's what we want to pull out front. Now, what do we have left in brackets here? Well, the x is gone. It's been pulled out front, so I have a 2 remaining. And now here's maybe the little bit tricky part. We have 1 minus 3x cubed here. But what is the power that goes up here? Well, minus 2/3 plus this should give me 1/3. And if you think about that, minus 2/3 plus what gives you 1/3? That's actually the number 1, right? Minus 2/3 plus 1 is 1/3. So that's what we're going to put there. And you know, since it's a power of 1, I don't even really have to write it. There's no use me writing the power of 1 there. So this usually happens. Usually when you do have these fractional exponents from a product rule like this, and you factor out the correct factor here, usually at the end you don't end up with any fractional exponents there. And it's just kind of an interesting phenomena that happens. So we've correctly factored this first term. What about over here? We have a minus. This 3 is still there. This x to the 4th has 1 and x being pulled out, so it's only x cubed now. And this entire expression 1 minus 3x cubed to the power of negative 2/3 has been completely pulled out front, so there's like nothing left there. And so we can close our bracket. And, well, I guess we can clean up that bracket a bit. What do we have? 2 minus 6x cubed minus 3x cubed. I'm noticing this negative exponent here. I'm wanting to bring that to the bottom, so let's do that. 2 minus, and this combines to give us 9x cubed, all over this same thing, except now it'll be to the positive 2/3. And that's all there is for that one.